In this video, you will learn to multiply two decimals together, to multiply a decimal with a number by using the distributive property, to estimate the product of two decimals, and how to use mental math to multiply a decimal by powers of 10. So beginning with objective 1, multiplying two decimals together. So your process of multiplying decimals is as follows. First, you want to multiply the numbers like normal, and then you want to determine where to put the decimal point. Now, where to put the decimal point, to do that, you want to see how many digits are after the decimal point in both factors combined. And then from there, you move the decimal point that many places to the left. So for example, if we had 8 times 0.4, so if you multiply the numbers like normal, 8 times 4, that would give you 32, right? So we've taken care of step 1. And now from here, we want to determine where to put the decimal point. So we see that the second factor right here, there's only one number after the decimal point, which means the decimal point moves from here over one place to the left to give you 3.2. So 3.2 would be your solution. Here's another example. If we had 0.8 times 0.4. Again, you multiply the numbers like normal. 8 times 4 would give you 32. But notice here, we have one number after the decimal point in the first factor, and then one number after the decimal point in the second factor. So you add those together, we have 2 digits total after the decimal point, which means that we move the decimal point 2 places to the left with the number we got. So with the 32, move the decimal point 2 places to the left, that gives you 0.32. Okay, let's try a couple more. Example 5, we have 0.57 times 0.4. Now again, we're going to take the numbers 57 and 4 and multiply like normal. We're going to get 28, carry the 2, 4 times 5 plus 2 would be 22. So we have 228. Now the question is, where do we put the decimal point? Well, we had one digit here after the decimal point and 2 digits here after the decimal point. So total, there was 3 digits after the decimal points. So that means we move the decimal point in our answer 3 places to the left. 1, 2, 3, which gives us 0.228. Example 6, we have 5.7 times 0.4. So again, we take the numbers 57 and 4, multiply like normal, and we already said over with example 5, that would give us 228. Now here, with these numbers, to figure out where the decimal point goes, we have one digit after the decimal point for the 5.7, and then one digit after the decimal point with the 0.4. So together we have 2 digits after the decimal point, which means we must move the decimal point 2 places to the left with our solution. So that would give us 2.28 as our answer. So that is multiplying two decimals together. Next, we're going to work with multiplying a decimal by using the distributive property. Now, when this comes in handy is when you're trying to perform mental math. So if you're trying to do calculations in your head, this is when this process will come in handy. So for example, if we had 3 times 12.5. Okay, the process for this is we want to take the 12.5, so the decimal, and write this as an addition problem. So the 12.5 you can write as 12 plus 0.5. So from here, okay, the 12 plus 0.5, we can now distribute the 3 in front to that. So we have 3 times 12 and 3 times 0.5. So that is our distributive property. We multiply the 3 by both parts. So 3 times 12 plus 3 times 0.5. Well, 3 times 12 is 36. And then 3 times 0.5, we do 3 times 5 to get 15. There's one digit here after the decimal point. So that means we move the decimal point 1 place to the left, which gives us 1.5. So we have 36 plus 1.5, which would give 37.5. and that is our solution. All right, here's another example. Example 2, we have 8.3 times 6. Now when you do this, we want to write the whole number first. So we write the 6 in the front. So the 6 would go first, times 8.3. And then the 8.3 we can write as an addition problem of 8 plus 0.3. Now from here we can distribute the 6 to both parts. So we have 6 times an 8 and 6 times 0.3. Well, 6 times 8 is 48, and 6 times 0.3, we'd have 6 times 3 is 18, and there's one digit here after the decimal point. So we move the decimal point one place to the left, which gives us 1.8. So 48 plus 1.8 is 49.8, and that is our solution. So this, again, comes in handy when you're trying to do this in your head. Now, you wouldn't have to write all these steps out like this, but you should at least be thinking through those steps in your head. Now, our third objective is estimating the product of two decimals. So working with estimating, our process is to round each factor to the greatest place. So typically this just means that we're rounding to the nearest whole number. Okay, and then from there you multiply the factors together. So for example, if we had 8.73 times 5.28. 8.73 we can round to the nearest whole number, which would be 9. It's closer to 9 than to 8. And 5.28 is closer to 5 than to 6. So we can round to 9 and a 5, and then 9 times 5 is 45. So our estimated answer is 45, whereas our actual answer would have been 46.1 if we rounded. Let's try another example. We have 15.09 times 10.43. All right, so here we can round the 15.09 to 15. It's closer to 15 than to 16. And the 10.43 is closer to 10 than to 11. So what we have is 15 times 10, which would be 150. And our actual answer, if we would have multiplied, would have been 157.4. So notice our answer is pretty close. So here we rounded to the nearest whole number to 15. Technically, if you're rounding to the greatest place value, you'd have to round to the tens place, which would be rounding to a 20. But when you do that, it's not going to be as accurate of an estimation, right? Because if you round the 15 up to a 20 to the nearest 10, you'd have 20 times, and then this would round to a 10, which would be 200. And that's much further off than our estimated answer of 150. So it's best if you can round to the nearest whole number, but there's times when you may find it simpler to round to the greatest place. So instead of rounding to the whole number, round to the nearest 10 or 100 or 1,000 or whatever. All right, let's try another example. Here we have example 3, and we have 0.17 times 12.63. So the 12.63 we can round quickly. It's closer to 13 than it is to 12. Okay, and then the 0.17, this one, if you round to the nearest whole number, it'd round to a 0, which we don't want that, right? Because 13 times 0 just gives us 0. But if we round to the greatest place, that would be rounding to the nearest tenth. So what we can do is round the 1 in the tenths place. You can round it up to a 2 because the 7 is bigger than 5 or bigger, so that would round up to a 2. So what we have is 0.2 times 13. Well, 2 times 13 is 26, and there's one digit here after the decimal point, which means move the decimal point over one place to the left, which gives us our answer of 2.6. So our estimated answer for example 3 should be 2.6. Now lastly, we're going to learn how to use mental math to multiply a decimal by a power of 10. So when we say a power of 10, what we mean is like 10, 100, 1,000, 10,000, 100,000, etc. And the process for doing this is we look at the number of zeros after 1, and that tells us how many places to the right to move the decimal point. All right, so if there is like 1,000, for example, there's 3 digits or 3 zeros after the 1, which means move the decimal point 3 places to the right. Okay, if there was 100, there's 2 zeros after the 1, so that means move the decimal point 2 places to the right. Okay, or the other way is if you have your power of 10 written with exponents, then the exponent tells us how many places to the right to move the decimal point. So for example, if you're multiplying by 10 to the third power, which by the way is the same thing as 10 times 10 times 10, or 1,000, the 3 is your exponent, but it's also the same number of zeros after 1. So here we just move the decimal point 3 places to the right. If it was 10 to the first power, for example, that would be just 10, or 1 0. So there's 1 0, and notice 1 is also the exponent. So the exponent and the number of zeros both tell us the number of places to move the decimal point. So let's try some examples of each, where you have just the zeros written after, or when you have the exponents. So with example 1, we have 532.659 times 100. So notice we have 2 zeros after the 1, which means the decimal point moves 2 places to the right, so it takes it after the 5. So our answer would be 53265.9. So 53,265.9. Example 2, we have 532.659 times 10 to the first power. So here, our exponent is 1, and by the way, 10 to the first power is just 10. So we have 1 0, also the exponent is 1, and that 1 tells us to move the decimal point 1 place to the right, which gives us 5,326.59. Example 3, we have 0.1539 times 100,000. So notice here we have 5 zeros after the 1, which means the decimal point moves 5 places to the right. So move it from here 5 places. We have 1, 2, 3, 4. We need to add a 0 at the end to move it over another place after the 9. So our answer would be 15390. So 15,390. And lastly, example 4, we have 0.0036 times 10 to the third power. So here, the exponent is 3. That means move the decimal point 3 places to the right, which gives us 3.6. So 3.6 would be our solution. And that concludes our lesson for today. We will see you next time.